Hello Earth Science students. For today's lesson you're going to need a blank piece of paper and a pencil. Side note, these Papermate Clearpoint pencils are by far the superior pencil. I've had this one since my first year of college and it is still going strong, and I'm a proud member of the 0.5mm lead club. But anyway, today's lesson is going to be about the basic units of measurement that we're going to be using throughout the year in science class. When we do any kind of data analysis or data gathering during labs. And this unit of measurement system that we use, of course, is called the metric system, which I'm sure you've heard of before. So as we go through this lesson, you're going to essentially recreate my notes sheet on your piece of paper, because that's going to be your assignment that you turn in. You're going to upload a picture of your copy of the notes to Teams, and that's how you'll get a grade for completing this. Okay, so the metric system. Almost every country in the world uses the metric system as their basic measurement system. The United States and then I think 2 other countries use the imperial system, just because we have to be contrary. But the metric system came about because a long time ago people used to measure stuff kind of however they wanted, and then that caused a lot of problems when you're trying to talk to other people about your measurements and they have no idea what you're talking about because they have no reference point for your measurements that you're using. So the metric system came about basically as a standardized unit of measurement and the purpose of that is to use those to streamline scientific communication. When everyone's measuring stuff the same way, it just makes it a billion times easier to communicate your data with other people. Okay, so we are going to do 2 column notes today. So take the left hand margin of your paper and fold it over by, I would say, about 1/3 of the way, so that we end up with 1 narrow column and 1 wide column for our notes. We're going to be putting terms here and then descriptions here. So our first metric measurement that we're going to talk about is length. And the base metric unit that we use to measure length is called the meter. And this is abbreviated as just a lowercase m. So of course you know that length is just how long something is. In our science class, we're going to measure this. Some tools that I'm sure you're already familiar with, you'll have to have used these at some point in your life. A metric ruler. So this is a ruler that has centimeters on it. It might also have inches, but it has to have centimeters on it also to be considered a metric ruler, or a meter stick. So let's just, sometimes I like to sketch little things just to remind myself what I'm talking about. So here's a little sketch of just a little baby metric ruler, just so you can remind yourself that's the kind of tool we're going to use to measure length in science class. Next metric unit is mass. We measure the mass of objects. The base unit for mass is the gram, abbreviated lowercase g. So mass is essentially a measurement of how much matter is in an object. Okay, so an important thing to remember is that mass is not the same as weight in all circumstances. On Earth, the two are pretty much the same thing because we live on Earth, and so the system of measurement was devised on Earth. But whereas mass is a measurement of how much matter is in an object, weight is more just like the relationship between the amount of mass and the effect of gravity wherever you happen to be. So that's like if you've ever heard that if you go to the moon, you're going to weigh a lot less. You might weigh 100 pounds on Earth, and then you take a ship up to the moon, and if you stepped on a scale, you would weigh like 40 pounds or something like that. And that's just because the effect of gravity on the moon is a lot less strong than the effect of gravity on the Earth. So mass and weight are not always the same thing. So we're going to refer to this as mass in science class. So in our class, we're going to measure mass with pretty much exclusively digital scales. You might have in middle school used those old school triple beam balance things where you have like, it's like this kind of thing with like two plates on either end, and you like, there's a little scale slide thingy in the middle that you can put something in the plate, and then like you have to move the little scale thingy on here to get it to match up. We're not going to use that. That's we've got fancy digital scales. We can use those. They're a lot more accurate anyway. Moving on. So next metric system measurement is volume. So volume is basically how much space does the object take up? We'll use good vocabulary here. How much space does an object occupy? So this, for the units that we're going to use most often for our science class, are going to be cubic centimeters, which is abbreviated as cm cubed, and then also milliliters, which is abbreviated as a lowercase m, capital L. So cubic centimeters and milliliters are equal to each other. So cubic centimeters, which we would use to measure the volume of a solid type of object, are the same amount of volume as a milliliter, which we use to measure liquid volumes. And this is important because it helps you to be able to measure the volume of weirdly shaped things, which we'll talk about in just a second here. So we're going to measure this with, for regularly shaped solids with regular shape, you are pretty much going to use the dimensions of the object and plug them into some type of formula that can solve for the volume of that object. So again, I'm just going to draw a couple little sketches here. So this would be like regularly shaped cubes or cylinders that have a regular shape. Anything that you can measure the dimensions of using a ruler and then plug those dimensions into a formula. That's how you'll measure volume for regularly shaped objects. For liquids, we're going to use a tool called graduated cylinder. For liquids, graduated cylinder is one of the few measurement tools that you can use to accurately measure the volume of a liquid. You can't use something like a beaker because beakers are meant to be kind of an estimated volume. Graduated cylinders are meant to be more of an exact volume. So let's sketch a little picture of a graduated cylinder. You guys will quickly learn that I am not the greatest artist, but I do try. So there we go. Here's our little example of a graduated cylinder, and they've got the little markings going up to the top, and then little pore spouts so that you can easily transfer liquids to other things. An important thing to remember when using a graduated cylinder to measure volume is, let's just sketch kind of a zoomed in view of what the sides of a graduated cylinder would look like, is that when you put liquid into a graduated cylinder, it does this thing. Oof, that's not very perfect. But the liquid kind of moves up the sides of the walls a little bit. So when you're measuring the volume of a liquid in a graduated cylinder, you always measure from the bottom of this little curved surface of the liquid that's in there, which is called the meniscus. You always have to remember to measure your volume from the bottom of the meniscus. Don't measure from the top where it creeped up the side. You always measure from the bottom of the meniscus. So that's for just liquids that you pour into a graduated cylinder. And then for irregularly shaped solids, so anything that's not like a perfect cube or a perfect cylinder or a perfect shape, irregular solids, we measure with the technique called water displacement. So since all of these volume measurements when they were created were based on how much space does just plain water take up, we can put water in a graduated cylinder, measure how much exactly there is, and then drop our irregular solid into that graduated cylinder, see how much the water level changes, and then we know that that's the amount of space that that object takes up. So again, let's just sketch. Here's our little meniscus, our original meniscus on our graduated cylinder, and then we drop an object in, and the height of that meniscus in the cylinder is going to change, and so you can measure what is the difference between where you started and what the water changed to, and you can tell that that is the volume of whatever object you dropped in the water. So our next, we're almost done here, we've only got 2 more. Our next metric measurements are going to be density. Oh, I'm running out of my little pencil lead here. Oh, that one's completely empty, we'll get a whole new pencil. So density is the ratio between mass and volume. So like how heavy is this thing versus how much space does it take up. So something with a high density is something that, like if you've ever picked up a rock and it feels heavier than it looks like it should be, that would be a rock that has a high density. So the formula that we use to calculate this is density is equal to mass divided by volume. So in order to calculate density, you have to have the mass and the volume of that object, and the units that your density will be in are going to be the mass, so whatever mass unit your object was measured in, per the volume. So whatever volume unit your object was measured in. So our very last metric type of measurement is going to be temperature. And temperature is measured in, I'm kind of running out of space here, Celsius, degrees Celsius. So this temperature scale is based on the freezing point and boiling point of water. Water, when it freezes, they just called that 0 degrees Celsius. Water, when it boils, they just called that 100 degrees Celsius. So it's a nice scale from 0 to 100. It's easy to measure with. The Fahrenheit can be more confusing because it's like water freezes at 32 Fahrenheit, water boils at 212 Fahrenheit, and that's just a much more confusing scale. Metric is nice because it's kind of based on a base 10 system, so it's easier to calculate, to like make conversions in your head. So we're going to measure this with a tool, you guessed it, the good old thermometer. Good old thermometers we're going to use to measure thermometers in science class, or to measure temperature in science class. So here is an overview of kind of what your notes sheet should look like. If you ran out of space and had to go on the back of your paper, that's fine. I was just trying to keep it on one side for ease of viewing at the end here. So make sure that when you take a picture of this, you get a really good clear picture so that I can read everything that you've got on there. Go ahead and put your name somewhere at the top so that I know that it's your paper and not somebody else's paper that's getting turned in. And you will take a picture of this and get it uploaded to Teams. If you need any help with that, just let me know.